Hello, today I'm going to talk about the chemistry work program that I've developed for my Ribbit State High School. Um, it's a 2-year work program for chemistry over years 11 and 12. Consists of 8 units, 2 per semester. 6 of those units have been contextualized. It also includes an outline of the summative assessment. One instrument has been included per unit, covering multimodal, ERT, EEI, and supervised assessments, one of each type per year. So in drawing up this work program, I had to choose a program planning model, and I chose the ADDIE model because I felt like it was while it appeared a simple model, it's actually quite intuitive. And allows a lot of flexibility, and it incorporates evaluation at each stage, so allows for revisiting and improving different aspects of the program as it's being developed and not waiting for the final outcome before you start reviewing and assessing. I did look at other programming models, and my other model that I really liked was the TABA model. Because I felt it was a good model for beginners. It was quite prescriptive, it had lots of direction, but I felt that those strengths could be incorporated easily into the ADDIE model. The other models I looked at briefly were Tyler, Dick and Carey, and I felt that they really addressed learning experiences and didn't incorporate the inclusion of critical thinking and problem solving into the work program, and also were limited in their evaluation. It was not as extensive as in the ADDIE model. So also in looking at the structure of the work program, I looked at the QCAA review checklist. Ultimately, the work program needs to pass this review before it can be rolled out to students, but also the organizing principles of the QSA syllabus, which look at increasing the complexity of the key ideas and concepts being rolled out over time, and including a range of assessment types and learning experience to accommodate different types of learners. And also looking at the sequencing and development of the key concepts and ideas, so really incorporating a spiral curriculum to allow the drip feeding of ideas and concepts, and also allowing them to be revisited over time, so the students are exposed to the same key ideas and principles multiple times over the course of the work program. So also I looked at the learning environment, the needs of the students, and really this meant using a contextualized delivery that was student-centered. And so really looking at context-based learning for students, because it's been shown to increase motivation in students and also foster their interest in further study. So looking at these principles that I've incorporated, so it's allowing the use of context and applications of science as a starting point for developing scientific understanding. So this really meant making the curriculum relevant to the students' everyday lives, looking at the work of scientists in their community, what they were doing and how it impacted on those students. And this meant conducting a situational analysis, looking at the needs of the students, looking at the situation into which the curriculum would be placed, like what's the environment in which it would be taught, both at a classroom level, a school level, a community level, and so on. And on top of that, so looking at student-centered and active learning, and these ideas are probably more incorporated at a unit level rather than a work program level. Back to the unit level, CBE principles, so introducing and developing scientific ideas via spiral curriculum. So drip feeding of information stimulated by student interest. So students can ask the question, they've heard this before, they're encountering this idea again, and they're asking questions, and they're learning on a need-to-know basis. It also allows for different ability levels to be catered to by altering the depth and breadth of the information depending on the student requirements. So how is this incorporated into the work program? Well, I had to look at the situational analysis and looking at how I could make the ideas, the key ideas, relevant to the students' everyday lives. So looking at the work of scientists in their community, or looking at the work of engineers and their families. So the first of all was looking at mining, and using that to teach atomic structure and the periodic table. So many families in Mount Ribbit are involved in the mining industry or supplying the mining industry. So this is a real-world application of basic chemistry principles. And again, in the second unit, looking at rates of reaction, equilibrium, industrial chemistry. There's an explosive factories in Mount Ribbit. And we know from our situational analysis that the school has strong community links. So bringing that industry into the classroom, my suggestion was a virtual tour of the factory and talking to an engineer. And this is an important opportunity to introduce a female engineer into the classroom. So looking at role modeling for females in the classroom and showing females in an industry where they are vastly underrepresented, but also underrepresented in the chemistry classroom. We have low rates of female involvement in chemistry. And again, looking at the real-world application of chemical principles, bringing the community into the classroom, bringing that industry into the classroom and making it relevant to the students' everyday lives. And the next one does that in particular, the analytical chemistry unit. So looking at the water treatment at the fertilizer factory and the discharge from that water treatment plant into the town's waterways. How does that discharge impact on the quality of the water in the waterway? Students from various backgrounds will have different ideas about the use of fertilizers. As we know, we've got some students from farming families, we've got some students from families that engage in alternative lifestyles that don't promote the use of fertilizers. So this is an opportunity to gather hard data so that they can evaluate the impact of fertilizer, which is a big contributor to the economy of the town. It employs a lot of people in the town, but also has the potential to affect the quality of the water where the town draws its drinking water from. So again, bringing that very much bringing those ideas and principles into the students' classroom in a way that's very, very relevant to them. So moving on to the contextualized units in year 12. So looking at redox, electrolysis, gas laws through marine salvage. So we have a marine salvage company in Mount Ribbit, and this is an opportunity for students to see the real-world application of chemical principles in scuba, looking at the gas laws, partial pressures, and also the use of redox for the preservation of salvaged objects, and linking to not only industry and community in town where they possibly know people that work, but also to the students' own interests. As we know, it's a coastal community where a lot of water sports. So linking scuba and the students' interests back to those gas laws again. So organic chemistry is an opportunity for the students to look at how therapeutic drugs are developed, and in doing so looking at organic chemical structures and reactions. To do this in a way that will be relevant to the students in this class, I will put an emphasis on the botanic origins of lots of our therapeutic drugs, and showing for those students that may be skeptical of big pharma, from families that maybe don't engage a lot with over-the-counter drugs, linking that back to their natural sources and just showing how it's evolved, how the active components, active molecules within those plants were identified, isolated, and then reproduced. And it's also an opportunity for discussion about the harmful effects of prescription drugs, that not all drugs that do harm are illegal or illicit drugs. And it's very relevant in a community that has an alcohol and drug problem. And then on to the last unit in the sequence of the work program, so biochemistry, looking at biomolecules and living chemistry. So linking this back to the work of the Mount Ribbit Council, where they're looking at alternative insect control methods. So why are they doing this? Linking it, so students and their families are affected by the diseases carried by these insects, and looking at the work of insecticides, how they work, how they interfere with enzyme production, and how this can affect the environment that they're used in. Discussions about DDT, how it affects the environment, so linking with the interest of those students from alternative lifestyles, but also looking at ways that this can be done without infecting the environment. So moving on to this key concept table, so this gives an outline of how where the key ideas are addressed over the course of the curriculum, and it makes it more obvious that this is a SPILE curriculum. Key ideas and key concepts are visited a number of times and over the course, so allowing for an increase in the complexity of the ideas. So ideas become more complex as time moves on, but also key ideas and concepts can be revisited in greater depth as students gain greater understanding. So looking at the evaluation plan that I would use, so a program of feedback from teachers and stakeholders at critical points ongoing through the planning process and capturing this via email, and then during the implementation process using online surveys to survey particularly students, to capture students' opinions on the course. So information is captured via email from teachers and staff, and during the implementation phase I would use a short survey of all students at the end of each unit of work using something like SurveyMonkey, where the results can be downloaded into Microsoft Excel, and use that to gauge their interest and how they engaged in the context and if they found it useful. And then capturing the teachers' opinions via email. So there's a record there of their opinions on student engagement during the implementation, pacing, selection of resources, and then it allows for revision along the way. So in developing this work program, it was a very solo experience, which I felt wasn't reflective of a school environment. There will be lots more input into this, and it was difficult to gauge pacing and time allocation in particular. And also there was no authentic knowledge of the students, so I was very much dealing in stereotypes in devising context especially. And I feel like first-hand knowledge of students would make this more authentic. Developing this in a school, I would make it a team effort and get feedback from teachers who may not, who have experienced the teaching program in the past, and because their insights would be valuable in the development of a new work program or adapting a work program, and also gaining authentic first-hand knowledge of the student cohort. I think would also allow context to evolve and become more nuanced and more relevant rather than dealing in those stereotypes. So this is an outline of the references used in this presentation. Thank you very much.